Okay, so we've been talking about the dosage calculations and those. Let's take a look at some of those now and see how we do with them, how well we remember them. So let's give you an example where we say a doctor orders a single dose of 50 milligrams of methotrexate. Actually, I want to change that. 60 milligrams of methotrexate for a patient who is 40 kilograms and height of 120 centimeters. So recommended dose or safe dose is 50 to 75 milligrams per square meter per week. Now, per week, it still can be administered as a single dose. Is this a safe dose? The strength, by the way, on the bottle, on the label, the label of the bottle says that the strength is constituted at 25 milligrams per milliliter. So if we take a look at this one, we're going to start out. The weight is given in 40 kilograms already, so we don't have to worry about converting our pounds into kilograms. So we're going to start out with the recommended dose here, 50 to 75 milligrams per meter squared. Now we're checking to see if this is safe, so I'm going to start out with the larger, the maximum dose. So it's 75 milligrams per 1 meter squared. We need to know how many kilograms or how many milligrams that'll be for however many meters squared this patient is. What we need to do, of course, the body surface area will be the square root of 40 times 120, remember it's height times weight or weight times height, divided by, for metric, 3,600. So let's see what we get there. Second square root, 40 times 120 divided by 3,600. 1.15 square meters, 1.15 meters squared. So that'll go down here. And now we cross multiply and divide. 75 times 1.15 divided by 1. Really just 75 divided by 1.15 gives us 86.25 milligrams. Doctor's orders of 60 milligrams did not exceed the 86, so we're okay there. Now let's double check just to make sure the dosage isn't too small. So we'll take the 86.25 milligrams and we're going to multiply by, now this one we used the 75, so that goes on bottom. We want to change it to the 50, so we're going to put the 50 on top. So we're going to take our 86.25 times 50 divided by 75 will give us 57.5 milligrams. So looking back up here, 60 milligrams is above the minimum. It's barely above the minimum for this patient, but it is still a safe dose. So this is still safe, it's just barely, because we have a range of 57.5 milligrams to 86.25 milligrams. The doctor's order for 60 milligrams, although it's on the low end, is still within that acceptable range. One thing you may have noticed here, we did not use that piece of information at all because we didn't need to. If we were to ask now what you're going to administer to the patient, we would use that, but in this case we weren't. We were asked to test to see if it was safe. Let's see, another one we want to do. One that we haven't done many examples of in class looks like this. have an order for Enduron, 3.0 milligrams POQD. PO means by mouth, orally. QD means 4 times a day. You have 0.75 milligram tablets. How many do you administer? Most tablets, by the way, you'll see the term grooved there. The term grooved, all that means is if you're looking at your tablet, grooved means that there's usually a notch in them, so that if you need to cut them in half, you can do that. Most of the time when you're talking about tablets, it's either a full tablet or a half tablet. So you have to learn to round them off. Let's do the math on this one and see how it turns out. So we'll start out with the doctor's orders. 3.0 milligrams over 1. And we're going to change that into tablets. So this is really 0.75 milligrams per 1 tablet. So the milligrams are going to go on bottom because we need to get rid of those. So 0.75 milligrams. 1 tablet then goes on top. Milligrams cancel out. We got 3.0 times 1 is 3 tablets. And 1 times 0.75 is 0.75. We've got to divide that out. That's 4 tablets. What if we ran into an example where it didn't come out exact? Let's say we had the doctor's order for, let's go 3.5 milligrams. And the bottle was once again 0.75 milligram tablets. So we got 3.5 milligrams over 1. We got to convert that into tablets. So milligrams and tablets. 1 tablet, 0.75 milligrams. Cancel out the milligrams. This is going to be 3.5 tablets over 0.75. We divide that out. 3.5 divided by 0.75 is 4.67 tablets. But we just said a groove tablet is either a whole tablet or a half tablet. So we need to ask ourselves, 4.67 is between 4.5 and 5. Which is it closer to? Well, 4.75 would be right in the middle. So all we need to ask is 4.65 bigger or smaller than 4.75? Well, it's on the smaller end, so that means we would round it down to 4.5 tablets. So for this patient, we would administer 4.5 or 4.5 tablets. Let's say we have an order from a doctor for a patient to receive 3 milligrams per meter squared weekly of Oncovin. Oncovin's a burn medication. On the bottle, the label, it says 10 milligrams per milliliter per patient. I'll give you the BSA. BSA is 0.8 meters squared. So the body surface area is 0.8 meters squared. First of all, let's figure out how many milligrams. Well, it says 3 milligrams per meter squared. So 3 milligrams per 1 meter squared. So how much is that for 0.8 meters squared? We'll cross multiply and divide. 3 times 0.8 divided by 1 is 2.4 milligrams. So 2.4 milligrams is how much that patient would need for milligrams. But then let's say how many milliliters. It's just a matter of converting the milligrams. We got 2.4 milligrams, and we could probably say per week or whatever, but let's not confuse it. So we go 2.4 over 1, and this is 10 milligrams per milliliter. So the milligrams have to go on bottom. Milliliters will then go on top, so 1 milligram over 10 milligrams, or 1 milliliter over 10 milligrams. Milligrams cancel. 2.4 times 1 is 2.4 milliliters. 1 times 10 is 10. You divide that out, it is 0.24 milliliters. So this patient requires 2.4 milligrams of medication. That'll be delivered in 2.4 or 0.24 milliliters of the serum. Any questions so far on those first few examples? Good. Let's say we need 400 milliliters of 7% solution of potassium chloride. That's solid. Potassium chloride. We're going to make it by, we have 12%. Basically, we're asking how much. How much of the 12% are we going to combine with sterile water to make 400 milliliters of 7%? So I'm going to do volume 400 times concentration of 7 equals the other volume we don't know, that's what's missing, times the concentration of 12%. This is going to be solved by doing 4 times 7 is 2,800. Solving for B, you're going to divide by 12. This is going to be 233.33 milliliters. So we would take 233.33 milliliters of the 12% solution. If we were asked how much neutral solution or normal saline to add, it would just be, if we're going to end up at 400 milliliters and we're using 233.33 milliliters of stronger solution, that difference of 166.67 milliliters has to be made up with the sterile water. So the tough part of that is realizing that you have to use that concentration adjustment formula. You could jump into a dilution there if you wanted to, but it'd be a little bit more difficult. If we knew the volume of the concentrated, the stronger solution, it would be easier to do a dilution there, but still the concentration adjustment formula is quicker and simpler to use. Since we're using that formula, let's look at another example. Let's say that we have 80 milliliters of 6% solution. We dilute it with water, with our sterile water, no more saline, to a volume of 320 milliliters. Find the new concentration. So once again, we have the volume and the concentration here, so 80 times 6 equals, we know our new volume is 320. We're looking for that new concentration. 80 times 6 is 480 equals 320C. And then divide by 320. It's 1.5%. So that new solution, after we dilute it, will only have a 1.5% concentration. Any questions on those? And Drummond there, are you trying to get the mic to work, or you have a question, or give me a wave if you're trying to, you're okay? All right. So anyway, let's take a look at something a little bit different. let's say we have an order for 0.1 gram phenobarbital. The label on the bottle says elixir GRSS per milliliter. We want to know you're going to be delivering this. It's a liquid, so it's going to be delivered in a syringe, and all of your syringes are labeled in milliliters. So we need to know how many milliliters this is going to be to administer to the patient. So we look at this. We have 0.1 grams. The G by itself is grams, remember. The label here says grains per milliliter. A lot of people make the mistake, well, GR has to be grams too. It's not. That is grains. GRSS is 1/2 of a grain per milliliter. There's nothing in this problem right now that equates grams to milliliters. We only have grains to milliliters, so somehow we have to convert grams into grains. Does anybody remember how many grains are in a gram? One gram is it 15? 15 grains. So I'm going to put my 1 gram over 1. So gram on bottom, grains on top. 15 grains over 1 gram. Grams cancel out. 0.1 times 15 is 1.5 grains is what we're being asked to deliver to the patient. Now that we have 1.5 grains, we can keep going with this. Put that over 1. Grains on bottom, milliliters on top. GRSS, that's 1/2 a grain per 1 milliliter. So the grains cancel. 1.5 times 1 milliliter is 1.5 milliliters. 1 times 1/2 is 1/2. 1.5 divided by 1/2 is 3 milliliters. So that patient will receive 3 milliliters of medication. Let's throw an easy one in here once. Let's say we want to find concentration after a 60% solution is diluted using a 1 in 4 dilution. This looks like it could be a complex problem, but it's really simple. When we take a solution where we know its concentration and we take it to a dilution, the new concentration is just the original concentration times the dilution. I don't know where the 2 came from. So 60 times 1/4, or 60% times 1/4, gives us 15%. So the new solution is 15%. Oh, let's say we have orders for 800 milligrams by a mouth of Motrin. Just a basic painkiller. The label is GRV tablets. These are tablets, but it says they are 5 grain tablets. This stands for 5 grains. We need to get from milligrams into the number of tablets, rounded to the nearest half tablet, I would assume. But first we got to take milligrams into grains. 800 milligrams 1 grain is 60 milligrams. So milligrams cancel. This is 800 grains over 60, which is what? 13.33 grains. So now I take 13.33 grains over 1. We've got 5 grains per tablet. Grains cancel out. We got 13.33 tablets over 5. You divide that out, and that is 2.666, 2.67 tablets. Again, we want to round that to the nearest half a tablet. 2.67 is between 2.5 and 3. It is closer to 2.5 tablets. Well, since we're talking about tablets, let's stay with it. So the order is 4. $300 milligrams. Well, let's do 400 milligrams. Over the course of a day. The label, the bottle is 120 milligram grooved tablets. Again, the groove just means we're definitely rounded off to the nearest half a tablet. 400 milligrams is the order, put it over 1. Here the milligrams got to go on bottom, so it's 120 milligrams per 1 tablet. Milligrams cancel out. 400 tablets over 120 divides out to be 3.33 tablets. Now I said they're grooves, so we're going to round to the nearest half. 3.33 is between 3 and 3.5. Which one is it closer to? Well, 3.25 is in the middle. 3.3 is bigger than 3.25, so it is closer to 3.5. Those are 3.5 tablets, 3.5 tablets. Well, let's see if I can give you one that'll fool you a little bit. So we got orders for 80 milliliters 4 times a day. The of Gaviston. Now let's see your bottle. Your bottle label says OZXII. Each dose is how many ounces? So 80 milliliters is our order, so 80 milliliters over 1. Each dose is how many ounces? Well, we've got an ounce, 13 ounces here, or 12 ounces here. So do we use the 12 ounces? Well, no, that doesn't say 12 ounces per milliliter. It's just a 12-ounce bottle. Now, all that would be able to do is convert ounces to bottles. Well, we don't have ounces. We don't have bottles, and we're not looking to convert to bottles. So we need some other way. Well, we look at this. We don't need a label to tell us. It's not asking us to change, use a concentration. We're basically just changing milliliters into ounces. If we look it up, putting milliliters on bottom, 1 fluid ounce is 30 milliliters. So cross-canceling the milliliters, 80 ounces over 30, which will divide out to 2.67 ounces. So it's one of those problems that looks difficult and you can really confuse yourself But when it comes right down to it, it's really basically just a conversion, unit conversion. Let's do a couple of flow rates here before we get done. Any questions on those last few? Okay. Let's say our doctor, let's say we've ordered $750 milliliters over 45 minutes. And the question is, how many milliliters per hour is that flow rate? Well, we want this milliliters per hour, so we're going to have to convert minutes into hours. That's 750 milliliters over 45 minutes. That's our original rate. We're going to convert minutes, so this time minutes go on top so that they cancel out over hours. 1 hour is 60 minutes. Multiplying out, 750 times 60, 45,000 milliliters. 45 times 1 is 45 hours. That divides out to be 1,000 milliliters per hour. Not as tough as it looks. Next, let's say you have orders to infuse 2,400 milliliters over 8 hours. Again, we want to know how many milliliters per hour that is. So 2,400 milliliters over 8 hours. Well, we're not changing the labels, we're just changing the numbers. So we want to know how much that is per 1 hour. We could use a proportion like this, but here, since this is going to be per 1 hour, we can just divide out. 2,400 divided by 8 is 300 milliliters per hour. So let's actually get into the drop factors and stuff like that. Let's take a look. Let's say that orders are for 1,500 milliliters infused over 8 hours. Let's say we want to know, first of all, how many milliliters per minute is this going to be? So we start out 1,500 milliliters over 8 hours. We'll do a conversion to get this into minutes. Hours and minutes. 1 hour, 60 minutes. Hours cancel out. To make this a little easier on myself, I'm going to cancel out 1 0. So I got 150 times 1 is 150 milliliters. 8 times 6 minutes is 48 minutes. I'm just going to divide that. 150 divided by 48 is 3.0625, I believe, milliliters per minute. We wouldn't necessarily take it out that many digits. Normally we would round off. If not told, usually you'd round off to 2 decimal places, so 3.06 milliliters per minute. But we weren't told here, so we just left it out. Now let's say to that same problem we're going to add a drop factor of, let's go with 12 drops per milliliter. So to figure out how many drops this would be per minute, we're going to take the 3.0625 milliliters per 1 minute. We're keeping the per 1 minute. We don't have to change that at all. It's the milliliters we're getting rid of. So milliliters on bottom, it is 1 milliliter, 12 drops per 1 milliliter. So the milliliters cancel. This is going to be 3.0625. Oops, I did do that wrong. Should have been 3.125, not 3.0625. So that'd probably round to 3.13 if we're going to round it. So this should be 3.125 times 12, which ends up being 37.5, I believe. There we go. 37.5 drops over. It's still 1 minute on bottom. So that is 37.5 drops per minute. Well, let's wrap that all into one problem. Let's say that we check an IV. We're going to go backwards with this one even. So we check the IV, and let's say the flow rate on the IV is 40 drops per minute. So it's a drop factor of 20 drops per milliliter. How long will it take to infuse 600 milliliters? So again, we have to work pretty much exactly backwards here. We start out with the flow rate. Normally we would end with the flow rate. Here we're going to start out with the flow rate of 40 drops per minute, per 1 minute. We're going to get rid of the drops. We're going to put drops on bottom. The only thing we have with drops in is the 20 drops per milliliter. So 20 drops, 1 milliliter goes on top. So we're now in milliliters per minute. Let's just go ahead and calculate that out to make it easier ourselves. 40 milliliters over 1 minute times 20 is 20 minutes, giving us 2 milliliters per minute. So now we have 2 milliliters per 1 minute. Now I'm bringing the 600 milliliters. This is going to be a proportion. We're still going to find minutes, and we have milliliters. We have the 600 milliliters. We're just changing the number of minutes. So we're going to cross multiply and divide. 1 minute times 600 divided by 2 milliliters gives us 1,200 minutes. Sorry, wrong way. Okay, divide, not multiply there. Gives us 300 minutes, sorry. So our time here is 300 minutes. But I just asked how long. If I wanted that in hours, put it over 1 times 1 hour is 60 minutes. If we figured that out, I'm just going to jump to it. That ends up being 5 hours. Any questions? All right. Show of hands, how many of you feel really confident about this exam coming up next week? Cool. How many of you don't feel anywhere near ready? How many of you don't care, just want to go home for Easter break? Okay, expecting to see more hands than the last one. Okay, we've got about 9.5, 10 minutes left, but let's call her good. No new homework today, but I would suggest you go back and review all this. The things that most people struggle with are the IV flow rates that we just finished with, and the dosages based on weight and body surface area. Those tend to be a problem. Now, the other thing that a lot of people tend to miss are some of the simple stuff because they worry so much about the more complicated stuff that they just kind of skim through it, like the simple dilutions, especially all the 3 different ratios that you can get from a dilution. For example, a 1:8 dilution, well, you have the 1:8 ratio, which is the serum to total. Then you've got a 1:7 ratio, which is serum to saline, and so on. You also have then the 7:8 ratio of saline to total, but that's usually not as useful. Then also just basic concentrations. Basic concentrations, if you're asked, 18% volume in volume solution has blank milliliters per, let's say 100, let's do it, let's complicate it, per 50 cc's of solution. Well, the first thing that stumps people on one like this is, what's 50 cc's? Well, 50 cc's is 50 cubic centimeters. And remember, the definition of a milliliter is 1 centimeter by 1 centimeter by 1 centimeter. So 1 milliliter is a cubic centimeter. So 50 cubic centimeters is 50 milliliters. So 18% volume in volume is saying 18 out of 100 is how many milliliters out of 50 milliliters. Cross multiply and divide, you get 9 milliliters here. So be careful of things like that. So that's pretty much it. I hope all of you have a great Easter weekend. We'll see you on Wednesday for our Unit 3 test.